Hi guys, welcome back. Today we are going to learn how to draw and interpret histograms. We've got 4 success criteria, and the first one is to interpret a histogram. So a histogram is a way to represent data. The bars of the histogram represent the frequency. There are no gaps between the bars of a histogram. The x-axis on a histogram is for continuous data, so data that can be measured. The y-axis on the histogram is always called the frequency density, and it's the area of the bar rather than the height that tells us the frequency. This histogram shows the heights of some plants John measured in his garden, and we're being asked how many plants did he measure in total. So for this we need to be able to read from a histogram. Remember, it's the area of the bar that tells you the frequency. So we can see the red bar has a height of 0.5 and it goes from 0 to 10. That means it's got a width of 10 and a height of 0.5. So the area would be 5. 10 times 0.5. For the amber bar, that's got a height of 0.7 and it goes from 10 centimeters to 30 centimeters. So that's a width of 20. So we do 20 times 0.7. So there are 14 plants between 10 centimeters and 30 centimeters tall. The green bar goes from 30 to 45. So that's a width of 15. And it's got a height of 0.6. So 15 times 0.6 is 9. So that means there are 9 plants in the garden that are between 30 to 45 centimeters tall. The blue bar goes from 45 to 70. So that's a width of 25 and a height of 0.8. So 25 times 0.8 is 20. That means there are 20 plants that have a height of between 45 to 70 centimeters. Finally, the purple bar goes from 70 to 100, so that's a width of 30. It's got a height of 0.2, so that means there are 6 plants that are between 70 centimeters and 100 centimeters tall. So altogether, if we add them all, that's 54 plants. Here's another example. So this time we're being asked to estimate how many plants are between 20 and 60 centimeters tall. So if we have a look at the area that's between 20 and 60 centimeters, so that's that area there. So the amount of plants that are between 20 and 60 centimeters tall is going to be the area of that shape there. Well, the area of the orange bit is 7. The area of the green bit is 9. And the area of the blue bit is 12. So that's a total area of 28 plants. So there were 28 plants between 20 to 60 centimeters tall. Here's one for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So this histogram shows the ages of people that visited the store, and we're being asked how many people visited the store. So to begin with, the red bar tells us how many people were aged between 0 and 5, so that's 1. There were 4 people aged between 5 and 10. There were 4 people aged between 10 and 18. There were 12 people aged between 18 and 30. There were 2 people aged between 30 and 40. And there was 1 person aged between 40 and 50. So that's a total of 24 people. Next, we were asked to estimate how many people were between 20 and 35. So that's that area of the histogram. So the area of the blue section is 10, and the area of the purple section is 1. So that's 11 people were aged between 20 and 35. Finally, we were asked to estimate how many people were aged over 25. So that's that section there. So the area of the blue bit is 5. The area of the purple bit is 2. And the area of the pink bit is 1. So that's a total of 8 people. This question says the histogram shows the time taken by some pupils to complete a maths test. 6 pupils took between 20 to 27.5 minutes. 12 pupils took between 27.5 minutes to 35 minutes. And we want to complete the histogram and calculate how many pupils took between 35 to 45 minutes. Well, the first thing we need to do is work out the frequency density. Now we know that 6 pupils took between 20 to 27.5 minutes. So the red section represents 6 pupils. So we need to work out the height of the red section. So if we divide that by the width, which is 7.5, that means the height must be 0.8. So now we can fill out the rest of the scale. So the next section goes from 27.5 to 35, and there were 12 pupils in that section. So to work out the height of the bar, we do 12 divided by the width, which is 7.5. So the height of the bar needs to be 1.6. So it looks like that. In the green section, we want to work out how many pupils this represents. So that's a height of 1.8 and a width of 10. So it represents 18 pupils. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So this histogram shows the weights of newly born babies at a hospital. 5 babies weighed between 2 to 4 pounds. 30 babies weighed between 7 and 10 pounds. And 15 babies weighed between 10 and 12 pounds. Complete the histogram and calculate how many babies weighed between 4 to 5 pounds and 5 to 7 pounds. So first of all, let's look at the red section. We know the red section represents 5 babies. So that means the area of the bar is 5. It's got a width of 2 because it goes from 2 to 4. So if we divide that by the width, we'll get the height. So it's got a height of 2.5. So now we can fill out the rest of the frequency density. So we're told there were 30 babies that weighed between 7 and 10 pounds. So that's an area of 30, and we need to work out the height. If it goes from 7 to 10, that's a width of 3. So the height must be 10. So the bar will look like that. It goes from 7 to 10 on the x-axis and we're on a height of 10. Then we can look at babies who were born with a weight between 10 and 12, and there were 15 babies. So the area is 15, and 10 to 12 is a width of 2. So that means the height of the bar must be 7.5. So it looks like that. Now we can work out how many babies weigh between 4 and 5 pounds. So that's a height of 10 and a width of 1. So that's 10 babies. And then the green bar is a height of 5 and a width of 2. So that's also 10 babies. Now we've completed success criteria 1. So now we're going to move on to number 2, and this is to calculate frequency density. So we know that the area of the bar tells us the frequency in a histogram. So the frequency is the height, the frequency density, times by the width of the bar. So when drawing a histogram, we will already have the frequency, but sometimes we need to work out the frequency density. And the width of the bar is also known as the class width. So the frequency density is the frequency divided by the class width. This table shows the ages of some children in an after-school care club. Calculate the frequency density for this data. So we add 2 extra columns on, one for the class width and one for the frequency density. Remember, the class width is the difference between the two inequalities. So the first class width will be 1 take away 0, so that's 1. The next class width is 3 take away 1, so that's 2. The next one will be 2, the next one will be 4, and the next one will be 1. So to find the frequency density, we do the frequency divided by class width. So 1 divided by 1 is 1, 5 divided by 2 is 2.5, 12 divided by 2 is 6, 10 divided by 4 is 2.5, and 7 divided by 1 is 7. Remember, we work out the frequency density as this tells us how tall the bar is. Here's 2 questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Okay, let's go through these questions. So for the first one, there's our class widths, and then the frequency density is the frequency divided by the class width. So there's the frequency density. For the amber question, we work out the class width. So there's our class width. And then for the frequency density, frequency divided by class width. And there's our frequency density. And now we've completed success criteria 2. So now we're going to move on to number 3, and this is to be able to draw a histogram. The table shows the heights of some Year 7 pupils, and we want to construct a histogram for this data. So the first thing we need to do is work out the frequency density. So we do the class width, and then the frequency divided by class width. and that tells us the frequency density. So now we can draw our histograms. So the first bar is going to go from 120 to 135 with a height of 0.8. The next one will go from 135 to 143 with a height of 2.25. The next bar goes from 143 to 145 with a height of 2.5. The next bar goes from 145 to 150 with a height of 2. And finally, the last bar goes from 150 to 160 with a height of 0.5. And there's our histogram. Here's 2 questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So for the green question, work out the class width, work out the frequency density, and then we can draw the histogram. So your histogram should look like that. For the amber question, work out the class width, then work out the frequency density, and then draw your histogram. So your histogram should look like that. And now we've completed success criteria 3. So now we're going to move on to number 4, and this is to apply to problem solving questions. So you can be asked some more challenging questions about histograms, which link into other topics. Try the next few challenge questions to get a feel for these questions. So for this question, Omar surveyed a group of workers to find their hourly rate of pay. His results are summarised in the histogram. The UK living wage is £7.85 per hour. A newspaper states that 1/5 of workers earn less than the living wage. Does Omar's survey support the statement in the newspaper? So if we start by working out the total, so we work out the area of each of these bars and add them together. So he surveyed a total of 250 people. Now 1/5 of 250 would be 50 people. So how many earn less than £7.85? Well, there's £7.85, so we want to work out the area of that chip there, because that's everything less than £7.85. So that's 2.5 times 12 plus 0.35 times 26, which is 39.1. So the survey doesn't support the statement, as only 39 workers earn less than the living wage, but 1/5 of the workers is 50. For this question, the histogram shows information about the time taken by cyclists to finish a cycle race. 7 cyclists took 80 minutes or less to finish the race. Work out an estimate for the percentage of cyclists that took between 95 to 110 minutes to 1 decimal place. So 80 minutes or less would be the red bar. So that's a height of 0.7. So now we can fill in the rest of the frequency density. So there's our frequency density along the side. So So now we can work out the total. So we work out the area of each of the bars, so the total is 90. Now let's work out how many cyclists took between 95 to 110 minutes. So that's 23. So the percentage, 23 out of 90, times by 100 to make that the percentage. So that's 25.6%. For this question, a survey was carried out to record the speeds of cars entering a village. The histogram illustrates the results of the survey. 40% of cars surveyed were fined for exceeding a certain speed as they entered the village. Calculate an estimate for this speed. So let's work out the total number of cars first of all. So we work out the area of each bar. So the total is 140. So 40% of 140 is 56. So that's the first 5 that were between 50 miles per hour and 60 miles per hour. So they would have been fined. Plus the next bar, the cars that were travelling between 40 and 50 miles per hour. So we need 16 more to get to 56. So we have a look in the third bar. So we need the area of the bar to be 16. We know the height of the fourth bar is 4. So the height of the green bar is 4. So now we need to work out the width for an area of 16. So 16 divided by 4 is 4. So 4 back from there would be 36 miles per hour. Averages from histograms. So this time we want to work out the height of the median plant. So remember, the median is the middle, so the middle plant. If we start by working out the total, so we work out the area of each bar. So that's a total of 54 plants. So the median value is going to be the 27th 0.5th value. So that's 5 plus 14, and we need 8.5 more, so we need to have a look at the third bar. So we need an area of 8.5, and we know the green bar has a height of 0.6. So to find the width, if the area is 8.5, we divide by 0.6, so that's 14.16. So we add that on to 30. So that's 44.16 centimeters. So the median plant would be 44.16 centimeters tall. For this question, we want to work out an estimate for the mean height of the plants. So again, work out the total. So that's 54 plants. And then we use the midpoint of the bars to work out the sum. So 5 times 5 is 25. 20 times 14 is 280. 9 times 37.5 is 280. 20 times 57.5 is 1150. 6 times 85 is 510. So that's a total of 2,245. So now we need to divide that by the total. So the mean height of the plant is 41.6 centimeters. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So for this question, we need to work out an estimate for the median age. So we start by working out the total. So there's 24 people in total. So the median value is going to be the 12.5 value. So we need to work out where that is. Now the first 3 bars represent the first 9 people. So we need 3.5 more of the 4th bar. So the 4th bar has a height of 1 and it needs to have an area of 3.5. So that means the width of the bar needs to be 3.5. So we move, if it starts at 18, we add on 3.5. So the median is 21.5 years of age. Here's another question for you to have a go at. Pause the video, and when you're ready to mark your work, press play. So this time we're being asked to estimate the mean. So again, we work out the total. So we've got a total of 24 people. And remember, we need to use the middle of each bar, and we times that. So 1 times 2.5 is 2.5. 4 times 7.5 is 30. 4 times 14 is 56. 12 times 24 is 288. 2 times 35 is 70. And 1 times 45 is 45. So that's a total of 491.5. So we divide that by how many people there are. So the average is 20.48. And now we've completed success criteria 4. So now that we've completed the last objective, it's time to end the video. Hope you enjoyed it and hope you found it useful. Make sure to like and subscribe, and be sure to check out the other videos on the rest of the channel. I'll see you next time. See ya.